8-5. We're going to look at explicit and recursive sequences. Alright, we're going to focus on the two main sequences that we learned in great detail in this chapter. We're going to look at the arithmetic one, and we're going to write the arithmetic two different ways. One way we're going to write it explicitly, such as an is equal a1 n minus 1 times d. We're going to also write it recursively in the same sequence. We can write it recursively, and we can write it this way. We'll say in order for us to obtain the nth term, we're going to take the previous term and add the common difference. Now we're going to look also at the geometric term, the geometric sequence, and write it two different ways. We're going to write it explicitly, and that way we will have an is equal a1 times r raised to the n minus 1. We can also write the geometric sequence recursively, and that will be a1 as long as we take the common ratio and multiply it by the previous term in order for us to obtain the next term. Let's go ahead and get started and see what section's all about. Okay, for question number 1, you're given a sequence. You have the first term is 2, and you're given it is the recursive sequence an equal an minus 1 plus 5. From this formula, you can tell this is arithmetic. They're asking you to find the first 6 term. Well, to find the first 6 term, you just need to figure out what d is, the common differences. And the common difference, as you can see from this formula, is 5. What this formula tells you, to get to the nth term, you take the previous term and you add a 5. So what you're adding every time is your common difference. So now, in order for us to get to the second term or to the third and all the way to the 6th term that they're asking you to do, we can go ahead and keep adding the common difference. So 2 plus 5 is 7, plus 5 is 12, plus 5 is 17, plus 5 is 22, plus 5 is 27. We can do it recursively this way, or we can do this. If we already know what n is equal to, n equal to 2, substituted into this formula right here, we will say a2, which is a subscript of 2 referring to the second term, it's going to be the second minus 1 plus 5. Well, a2 minus 1 is 1 plus 5. a1 is given to you to 2. 2 plus 5 is 7. You can do it this way for every single term till you get to the 6th term. For number 2, you're given f of 0 is equal to 1. And f of n is equal to 2 times f of n minus 1. Just because it's multiplication, it indicated to me it's a geometric. They gave you the formula recursively. That means the common ratio is 2. They're asking for the next. So in order for us to find the 6th term in this sequence, all what I need to do is keep multiplying the previous term by 2. So to get to the first term or to the second term or to the third, the fourth, and the fifth, that's what they want. We're going to take the previous term and keep multiplying by 2. So if the previous one is 1, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and times 2 is going to give us 64. Another way to look at this is this. If you let n equal to 1, we can do it recursively based on the formula. Substitute 1 in this formula will be f of 1. Whatever you see in n, substitute 1. And so this will be 2 times f of 1 minus 1, which is 2 times f of 0. F of 0 is given to you right here to be 1. So this will give us 2 times 1, which is simply 2. You want to keep doing this until you get the next 6 terms. Okay, for number 3, they're asking you to write a recursive rule. Well, we can write a recursive rule. We just have to figure out what type of sequence we're dealing with. You're given a sequence that's 9, 12, 15, 18, 21, and so on. The first thing I want you to know, determine the type of sequence you're dealing with. And since you can tell right here, you are continuously adding 3, positive 3 is going to be the common difference. Therefore, this is an arithmetic sequence. And to write the arithmetic recursively, I give you 2 different formula, and the arithmetic one is going to be an equal an minus 1 plus d. As long as you know what d is, the formula, the recursive rule will be an minus 1 and plus 3. This is what they're asking for. You're done. For number 4, they want you to write a recursive rule for this particular sequence. So now let's state the sequence and determine what type of sequence it is. So if we know what type it is, we can probably go ahead and figure out what the rule should be. And so now if you look at this one here, what are we doing from one term to the next? And as you can see, this is going to be multiplying it by 2/5. Test it again to see if you're continuously multiplying by 2/5. Once you figure out this is the common ratio, that's a geometric rule, a geometric sequence. So the rule should be an is equal to r times the previous term. And I give you those formula at the beginning of the lesson. Keep them in mind. This is the recursive rule. Okay, for number 5, you're given this particular sequence, 3, 4, 1, -3, -4. Well, we have to determine what type of sequence that is so we can write a recursive rule. Well, if you look at this one here, the first term is 3. The next term is 4. The next one is 1. So how did they get a 1 over here? Maybe they took 2, the second term, and subtracted the first term. So if they take 4 minus 3, they get a 1. Let me test it. So if to get the fourth one, can I take a 3 minus a 2, the previous 2 term, and subtract them? And so that will give us 1 minus 4, which is -3. So now I notice how they're working on this. They're subtracting the previous 2. So to write the rule, I'm thinking an, it should be the an minus 1 subtract the previous one, which is -2. Okay, number 6. Number 6, we have to look at that sequence and determine what type it is. It is not arithmetic, it is not geometric. I wanted to look for a pattern and see what's going on and write a rule. So we're asked to find a recursive rule. And as you can see here, it is not arithmetic, it's not geometric, there's no common difference, there's no common ratio. I'm just looking at that sequence and see how do they do this. If the first term is 1 and the second one is 1, what did they have to do to get to the third term? Well, I'm gonna think maybe they took, in order for us to get a third, maybe they took 1/3 of a of 1, which is a2 or a1. And so that gave us 1/3. So to get to the next one, what did they do? They did 1/4 of 1 again and gave me a fourth. And so now let me see if I can find a pattern. To get to the fifth term, which is 1/15th, maybe they did 1/5 of 1/3. And so what they did here, it's the fifth term of a 3 times 1/5. And so to get to the sixth term, they're going to get 1/6 of which term? The fourth term. And so now if you continue this pattern, you will find the nth term is going to be 1 over n, an minus 2. Not the previous one, but 2 back. Okay, number 7. To do number 7, we're given a rule and we're asked to write it recursively. And as long as you recognize this is arithmetic, I gave you this formula 2 different ways at the beginning of the lesson. The arithmetic recursive, it's an equal an minus 1 plus d. Well, in order for us to go from here to here, all what you need is to find what d is. To find what d is, list the first 2 terms. The first term will be 5 minus 3 times 1, which is 2. The second term will be 5 minus 3 times 2, which is -1. So in order for us to find the common difference, and in this case you will know it's the common difference of -3. Common difference of -3, the recursive rule for the arithmetic will be an minus 1 minus 3. Now what I want you to do, try number 9. 9 goes exactly the same, and the answer to number 9, it should be an, which is equal to an minus 1 plus 8. Okay, for number 8, you're given this rule, which is an equal 10 times negative 2 to the n minus 1. I want you to recognize it's a geometric rule. It's written explicitly, and I'm asking you to write it recursively. Recursively, it's going to be r times an minus 1. So all what we have to do is find out what the common ratio is. List the first two terms and then figure out what r is. This one is going to be r times negative 2 to the 0, which is 10. A2 will be 10 times negative 2 to the 2 minus 1, which is going to give you negative 20. And so the common ratio in this case was going to be negative 2. To write the formula recursively, it's going to be an is equal negative 2 an minus 1. Now I want you to try number 10. And number 10 is exactly the same. And I'm going to give you the answer, and I hope you work it out. It's an equal 3/4 an minus 1. Okay, number 11, we're going the other way. They're giving you the first term, which is negative 1, and they're giving you the formula or the rule recursively, and you're asked to write it explicitly. Now, you need to recognize this is arithmetic, and as long as you recognize this is arithmetic, this is your common difference, which is d. Now, to write the formula you need a1, or the rule, and you need a d. And to write it, it's an is equal to a1 n minus 1 times d. a1 is negative 1 and d is 7. You must simplify this into negative 1 plus 7n minus 7, or simply written as an is equal to 7n minus 8. Now what I want you to do, try number 13. Number 13 is exactly the same, and the answer should be an equal 1.3 minus 0.3 n. Okay, number 12, you're given the first term to be 24, and you're given a rule that is written recursively, and you're asked to write it explicitly. I want you to recognize this rule is geometric because you're multiplying r by the previous term. And now to write it explicitly, remember before when we wrote it explicitly, we needed to find r and we needed to find a1. Both of those are here, so to write it, it's going to be an equal a1 times r to the n minus 1. This is the geometric sequence rule written explicitly. Now I want you to try number 14. And to try number 14, which is exactly the same, you're given a1 is negative 2. You go ahead and find r, which is negative 5. And to write the rule is an equal negative 2 times negative 5 to the n minus 1. Do your homework. Good luck. I'll see you Tuesday.